Hi guys, we are on 9.4, day 6 and 7 notes. We are going to start solving our trig equations. So a few different methods for solving. We want to use our unit circle or our calculator. We're going to factor, use those trig identities, and if we square both sides of an equation, then we need to make sure that we are checking for extraneous solutions. And we are going to rewrite our tangent as sine and cosine. Okay, and we do want to make sure that our solutions are on the interval 0 to 2 pi, or if we're writing all solutions, then for sine and cosine, we use plus or minus 2 pi k, and for tangent, we use plus or minus pi k. Before we get started, I'm just going to sketch out the first quadrant of the unit circle, because if I know the first quadrant, then I know everything else. My trick is just to write 1, 2, 3, and then 1, 2, 3 going back down. Everything has a square root in the numerator, and everything is divided by 2. Okay, so we've got pi over 6, pi over 4, and pi over 3. And then the last thing I just want to write down is all students take calculus, so I remember where things are going to be positive or negative. And then just some trig identities that may come in handy. So we should know these already and have these memorized, but sine squared plus cosine squared is equal to 1. Tangent squared plus 1 is equal to secant squared. And then cotangent squared plus 1 is equal to cosecant squared. Okay, so let's go ahead and get started. So this first one says cosine of theta is equal to 1/2. So I know that on my unit circle, all my coordinates are written as cosine and then sine. So cosine is x, sine is y. So if I want cosine to equal 1/2, I am looking for the x value of 1/2. So that happens at pi over 3. Okay, but x is also going to be positive in quadrant 4. So that would be when theta is equal to 5 pi over 3. So those are my two solutions. But if we want to write it as all solutions, that would be pi over 3 plus or minus 2 pi k, and then 5 pi over 3 plus and minus 2 pi k. Okay, number 2, we have tangent of theta plus root 3 divided by 3 is equal to 0. So I want to get tangent of theta by itself. So I'm going to have tangent theta is equal to negative root 3 over 3. Okay, so tangent, that's just sine over cosine. So I have to see where is that going to get me root 3 over 3. So that's going to happen when we have root 3 over 2 and 1/2. Okay, because remember, if I have y divided by x, I can flip the second and multiply. So it would end up with 1 over root 3, which does equal root 3 over 3. So anytime I have root 3 over 2, comma 1/2, that is when tangent is going to equal root 3 over 3. Okay, but here I am looking for it to be negative. So using my all students take calculus, tangent is going to be positive in quadrants 1 and 3. So it would be negative in quadrants 2 and 4. Okay, so root 3 over 2, 1/2 occurs at pi over 6, but I need one of the coordinates to be negative, not both. Okay, so that is going to happen in quadrant 2 at 5 pi over 6, and also in quadrant 4 at 11 pi over 6. if I were to write down all solutions, okay, when we use tangent for all solutions, we only need to plus and minus pi k. So I would say that this is 5 pi over 6 plus and minus pi k. I don't need to include the 11 pi over 6 because 5 pi over 6 plus pi would get us 11 pi over 6. Number 3, we have sine squared theta minus sine theta minus 6 equals 0. So right away, this looks like x squared minus x minus 6 equals 0 to me. And I know that that's easily factorable. So we can factor this to be sine theta minus 3 times sine theta plus 2 equals 0. Now let's set both equal to 0. So sine theta is equal to 3, where we have sine theta is equal to negative 2. Okay, well, sine of theta never equals 3, so that would be no solution. And sine theta equals 2, that doesn't happen either. So this one is just no solution. Number 4, we have 2 cotangent squared x plus cosecant squared x minus 2 equals 0. Okay, well, I can't really have two different trig functions here, but I do know that I can change cosecant squared x to cotangent squared by using one of our identities that we wrote above. So I'm going to rewrite this to be 2 cotangent squared x plus cotangent squared x plus 1 minus 2 equals 0, since this is our identity. So if we rewrite this, I have 3 cotangent squared x minus 1 is equal to 0. 3 cotangent squared x is equal to 1. Cotangent squared x is equal to 1/3. Okay, so from here, let's take the square root of both sides. So I have cotangent x is equal to the plus or minus square root of 1/3. So if I rationalize the denominator, I'm going to end up with root 3 over 3 and also negative root 3 over 3. Okay, well, just up above in number 2, we were looking when tangent was root 3 over 3, and that happened at root 3 over 2 and 1/2. So this time with cotangent, this is going to occur when we have the coordinates of 1/2 and root 3 over 2. Okay, so cotangent is going to be positive in quadrants 1 and 3, and it's going to be negative in quadrants 2 and 4. So to get root 3 over 3 to be positive, this is going to occur at pi over 3, and also then in quadrant 3 at 4th pi over 3. Okay, and it's going to be negative, so we can say x equals. Okay, so these are for my positive answers. Now my negative answers would be when x is equal to 2 pi over 3, and then also in quadrant 4 at 5 pi over 3. Okay, now if we write all solutions, we would have pi over 3 plus and minus pi k, and then we'd also have 2 pi over 3 plus and minus pi k. Number 5 is sine of t is equal to negative 0.301, and we want that to be from 0 to 2 pi. So you are going to need your graphing calculator to do this problem. So to solve for t, we'll take the inverse of sine, or the arcsine. So we could say t is equal to arcsine of 0.301. Okay, so I'm going to go ahead and type that into my calculator. So please make sure that the mode is radians. So then we can go ahead and hit second, sine negative 0.301, and we end up with negative 0.306. So t is equal to negative 0.306. So sine is negative when we are in quadrants 3 and quadrant 4. Okay, so to find out my final answers, to find out when we are in quadrant 3, that's going to be somewhere over here. So to do that, I am going to take pi minus whatever theta is, so t is equal to negative 0.306. So if you type that into your calculator, you end up getting approximately 3.45. Okay, then to find it in quadrant 4, we can go ahead and just take 2 pi and then subtract 0.306, and that gives us approximately 5.98. So in quadrant 4, it would be right here. So that's why I just want to take 2 pi and subtract out the angle. So t is approximately 3.45 and 5.98. Now, if it asked for all solutions, I would just be adding or subtracting 2 pi k.